Until now, we have discussed what is return, and we have also discussed what is risk. We also looked at both of their calculations, and we differentiated them in the case of standalone and portfolio. In the context of portfolio, we discussed that some of the risk can be diversified away, and the only relevant risk in this case is the market risk. Which is measured by the beta coefficient. Then we also discussed the capital asset pricing model, and how through this model we can estimate the required rate of return for a given level of risk. So now we know, now we can estimate what will be the required rate of return. So now we can actually calculate the portfolio's return. So we know how to calculate the portfolio's return, and we have also discussed the portfolio's risk. Now you can form so many unlimited portfolios by using different combination of stocks each time. The question is that which combination of stocks is the best option. So for that, we have the efficient portfolios, which are defined as those portfolios that provide the highest expected return for any degree of risk or the lowest degree of risk for any expected return. Remember that investors like return and they dislike risk. So for the most efficient portfolio will be the one that offers the highest expected return or the lowest degree of risk for any expected return. So that is your efficient portfolio. This will become more clear when we later on look at its graph as well. Now this is the two asset case. So over here we are going to assume that there are only two assets, stock A and stock B. Now if you want to calculate the return of portfolio, you already know how to do that. It is the weight of stock A multiplied by the return of stock A, 1 minus WA. So this means WB because there are only two stocks in the two asset case, and multiplied by the return of B. Now we also have the portfolio standard deviation formula. So if you want to calculate the standard deviation of the portfolio, this is the formula for that. We have already discussed in this what is correlation. Remember, because of correlation you can actually form riskless portfolios as well if the correlation is perfectly negative. But we discussed that usually the correlation tends to be close to 0.3. So you can reduce risk but you cannot eliminate it. So this is the formula where again WA is the weight of stock A, the standard deviation of stock A. So basically this is a variance because you can see there is a square over here. So the variance of stock A, then you have WB, then you have the variance of stock B, then 2 WA, WB, and the correlation between stock A and B, and then the standard deviation of A and the standard deviation of B. So let's look at an example of how can we use this formula. So expected return of A is 5%. So you have RA, that it is 5%, and a standard deviation of return for A is 4%. So let me just write this down over here, that the expected return for A is 5% and the standard deviation of A is 4%, while expected return of B is, so the expected return of B is 8%, and the standard deviation of B, and the standard deviation of B is 10%. Assume WA is 0.75. So the weight of stock A is 0.75 and this is the weight of A, then the weight of B will automatically be 0.25 because this should add up to 1. And the correlation between A and B is 0. So the correlation between A and B is 0. What is the return and risk of the portfolio? So if you want to calculate the return, the formula for that is WA multiplied by RA plus, so I'm just going to write WB and RB. So this is 0.75, this is 5% plus 0.25 and this was 8%. So if you solve this, your answer will come 5.75%. So this is the return of the portfolio. Now we will also calculate the standard deviation of the portfolio. I'm going to erase this. Okay, so we were calculating the standard deviation of the portfolio now. So just erase this. So the formula is WA squared, then we have variance of A plus 1 minus WA, which means this is WB square, and the variance of B plus 2 WA 1 minus WA correlation AB, then standard deviation of A and standard deviation of B. So this is our formula. Over here we have 0.75 square then over here we have the standard deviation of A square, so that's 4%. So 0.04 and square here, I'll use brackets, plus we have WB, so that is 0.25 and its square, and then we have 10%, right? 10% and its square plus 2. WA is 0.75, this is 0.25. Correlation between both of them is actually 0, and then we have 4%, and then we have 10%. So if this is 0 and this is multiplying with the whole thing, this whole thing will become 0 over here. So we are left with 0. And solve this. This is 0.0009 plus 0.0000625. And you sum this up, this is 0.001525, 0.039 or 3.9% is the standard deviation of this portfolio. Okay, so this is the efficient portfolio diagram for 2-asset case. So are all combinations on the attainable set equally good? So if you look at the attainable set, that how do you get the attainable set first? So what you will do is you will keep on using different weights over here. So you might try 0.75, then 0.25, then 0.5, 0.3. You will keep on fluctuating these weights over here, and also in order to get the complete attainable set. So once you have exhausted all of your weights, you will get the whole attainable set from it, like all the combinations of return and risk for the portfolio. In the previous case, the WA weight was 0.75, right? It was 0.75 and WB was 0.25. So this combination gave a return of 5.75% in the portfolio and a 3.9% standard deviation for the portfolio. And if you vary these weights, so if you keep 0.6 and then 0.4, this will change every time. The return and the risk of the portfolio will change. So if you keep on calculating, you will get the whole attainable sets, which are many combinations of the portfolio. So over here, this is the risk on the horizontal axis and this is the return on the vertical axis. So even over here, this is your attainable set. So these are all the combinations. So A, this point is if you do 100% investment in stock A only. And this point B represents if you do 100% investment in stock B only. And as you start to differentiate the weights, so if you start fluctuating the weights, so now you are investing 0.9 in A. So you will be over here, and then you decide no, you will invest 0.8 in A, 0.7, 0.6 and so on. As you start to decrease the weight of WA and increase the weight of WB, you will move this way. So if you look at the attainable set, which point do you think would be the best combination? So only that part of the attainable set from Y to B is defined to be efficient. So the only efficient part over here is the part from Y to B. So this is your efficient set over here. The part from A to Y is inefficient because for any degree of risk on the line segment AY, a higher return can be found on line segment YB. Now why is actually YB the efficient set? Because if you are, let's say at this point, if you are at this point, so an investor can, for the same amount of risk, he has the option of a higher level of return. So he will actually choose this combination. This one would be better. Why would he go for a lower level of return at the same amount of risk when he has the option of getting a higher amount of return for the same level of risk? So that doesn't make sense. So your investor will shift over here in that case. Similarly, if you are at this point as well, again for this amount of risk, you can see that a higher level of return is available. So again your investor will shift to that side.